Hey GED students, it's GED question of the daytime, and I am still hitting up those place value equivalent expressions. Really want to lay this foundation deep and strong so that you have a much easier time with so many other math concepts. So it says match each number below with an equivalent expression on the right. And again, I would just ask you guys to pretend that I had A, B, C, D, E here, and not two D's. Okay, and so each one of these numbers you can see is two somethings. A 2, no other important numbers, all the rest are just zeros, but a 2. But in all of these problems, the 2 is in a different place value, meaning that the 2 has a different worth, right? The worth of a number changes, or a digit changes depending on where it's placed in our place value system. So hopefully we'll ease into the concept with A. A says 2,000, meaning I have two things of size 1,000. Now remember what we learned 2 videos ago about the powers of 10. Our number system is a decimal system. Deci means 10. It's based on powers of 10 because we have 10 digits. So let's think about it. 10 to the 0 power is 1. Anything to the 0 power. And that's our first place. When you think about places of whole numbers, we have ones. Then after that, 10 to the first power is 10. And think about our next place value. When we do place value of ones, then we have tens. What do we have after that? Hundreds. And indeed, 10 to the second power, or 10 times 10, is 100. Similarly, if you took 10 times 10 times 10, 10 times itself 3 times, you'd have 1,000. And the place value system goes on like that. Ones, tens, hundreds, thousands, 10,000s, 100,000s, and they can all be represented with powers of 10. Okay, so let's take a look then at A, like we were saying, is 2 times 1,000. Or what is 1,000? But it's 3 tens multiplying. We end up with those 3 zeros. We know it was the same as 3 tens multiplying, or 10 to the third power. If you need a deeper explanation of this, that didn't make sense, look back to 2 videos ago, 2 question of the day videos ago. We did this exact same thing a little slower. So that's 2 times 10 to the third power. Okay, now it gets interesting once we hit the decimals. Students lose their mind. But let's look at what we have. We have 2. This time it's in what place? Well, remember counting decimal places, right after the decimal on the right, you start with the tenths, and then the hundredths, and then the thousandths. You move out from the decimal. So this is like 2 not thousands, thousandths pieces of size 1,000. Now you say, Kate, what in the world is that? That is 1,000th. You read the bottom of fraction with that TH on the end. But the really cool thing is we can totally express this with a negative exponent. That's the same as 10 to the negative third power. Okay, now you might be saying, Kate, that doesn't make any sense. I don't understand that. And maybe that's because you haven't learned about negative exponents. But can I show you this? Every time you take a number like 2 and times it by a negative exponent, each time you do it, you're losing value. So let's start with 2. Like plain old regular 2 is just like $2. It's like 2.00. Think about it that way. So the decimal's at the back end. Now, if I wanted to multiply that by 10 to the negative 3, each time I would lose a place of value. So that would be 10 to the negative 1, negative 2, negative 3. That decimal would end up there with 2 places in between. I lost 1, 2, 3 decimal places worth of value. Therefore, this is 2 to the negative third power. So B matches with 5. Okay, so now let's look at 200. That one's easier because it's a whole number. We're going to see those positive exponents. 2 zeros, easy. 2 times 10 to the second power. C matches with 3. Let me erase this work over here. Okay, let's look at D. D is 2 what? Well, tenths, hundredths, 2 hundredths. One way to write that would be 2 times 100th. 2 things of size hundredths, but that's not how this is written here. It's written with powers of 10. So what is hundredths? Well, it's like a 2. Think about 100 would be 10 to the second power. Hundredths those pieces and parts is just negative second power. You use the negative powers to represent pieces and parts, not negative numbers, which is weird for a lot of students. So D matches with 1. 200ths. I guess think of the negative as like TH. Okay, so now looking at the next one, we've got a 2. In what place? Well, the tenths would be the negative 1. Power, 10 to the negative 1. The next one, hundredths, would be 10 to the negative 2. Next one, thousandths, would be 10 to the negative 3. I hope I'm making sense now. Next one, 10 thousandths, would be 10 to the negative 4, but that 2 is all the way over here in the 5th place, the 10 to the negative 5th place. And so E matches with 4. That is 2 10. Oh, hold on. I think it's 100,000ths. Tenths, hundredths, thousandths, 10,000. Yeah, 200 thousandths, or 2 times 10 to the negative 5th power. Okay, excellent. Tricky, 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 but I promise you this exploration is worth it to fully understand both negative exponents and our base 10 number system. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.